In this lecture, we'll be learning about the data imbalance problem through a notebook presentation. Okay. We'll be working on a special data set, what we call credit card fraud detection. So let's load the data. And if you look at the size of the data, you'll find that we have almost around 285,000 records with 31 features. Okay. If we look at the data, if you'll find that they have several features, V1, V2, V3. So they masked the original feature names. And the last column actually contains the labels. So here you have the labels. Okay. So let's look at what are the different values of those labels, 0 and 1. 0 means that this is not a fraud case, and 1 means that this is a fraud case. Okay. So if I plot the data through a pie chart, you will see that almost about 99.8% of your data are actually a non-fraud case, and only 0.13% of the data are from the fraud levels, okay, with level 1. So you can see that this is quite a imbalanced data, so one have like a majority of the data set. So this is what we call majority class, and then this one we call it the minority class. Okay. So we follow the regular modeling steps, like we do the scaling of our features, and then we have a 50-50 trace train split. Okay. And if we train a logistic regression classifier, if you look at the accuracy, you will find that your model is doing a 99.86% accurate prediction. So you might be thrilled that, oh, my model is really doing good. Okay. But not actually the case is. If you recall, our data has 99.8% coming from the majority class, so that might actually confuse the model. Okay. And if you look at the confusion matrix, so you see that only 1/3 of the positive class or the fraud cases were detected by the model. So the model actually failed to detect more than 2/3 of the fraud cases. In summary, even your model is doing 99% accurate prediction, there is no value of this model. Okay. So that's why we have to rely on other matrices like precision, recall, and F1 score. So if you look at their corresponding values, we find that the F1 score is almost around 0.33. Okay, just keep this in your record, because F1 score talks both about precision and recall. We have another video, you can check on that. Okay. If you run the random forest classifier, it will take some time, so we will use previously run values. And here you can see that the accuracy is quite the same, but if you look at the confusion matrix, you see that random forest model was quite good in terms of identifying both the positive class, that means the fraud cases, and also the non-fraud cases. Okay. So you can see that it was able to detect 3/4 of the positive cases. So this is good. Okay. But this is reflected through the F1 score. Okay. You can see that compared to logistic regressor, the random forest model has a very good F1 score, 0.75. Okay. So let's look at how these values are using support vector machines. So here you see that this is even better. Okay. So 0.82. Okay. Using gradient boosting, you have not that good, but we have to learn some other things like hyperparameter optimization. But one thing is sure, that all these models have kind of similar accuracy, but for these kind of imbalanced data cases, you have to rely on matrices like F1 score or precision and recall. Okay. The accuracy cannot be a good metric because it actually doesn't tell the story uniformly across classes. Okay. You just bias towards the majority class. Hope this helps. If you have any question, you can reach out to me. I encourage you play with the notebook, and if you have any question, feel free to ask me at any time. Thank you.